So first, I'll start with saying what is Reddit. Reddit is large website, one of the largest websites, and Reddit is where people gather for conversations. They search for communities, and they find all the things that they care about. There's here a small thing from the r/SRE subreddit. And to achieve our goals and to achieve our skill, we use technology that we use is Kubernetes. We run where we run basically all of Reddit. We use gRPC quite extensively. In terms of programming languages, we use Python and we use primarily Go. And our scale is very large, so we serve tens of billions of requests per day. For this talk, we're going to be talking a lot about service discovery. Before I go into service discovery with XDS, I want to take a moment to talk about service discovery in Kubernetes, how it works out of the box. So in Kubernetes, we have pods, which are the units of compute. So service foo will have n pods, 1, 2, or 3. And those are managed by Kubernetes deployment. And then the deployment is being selected by a service, which gives networking to the pods. And also, Kubernetes offers for services through various controllers, DNS resolvers and DNS addresses. So service foo that runs on the namespace service foo namespace will have an address that is service.namespace.service.cluster.local. And then depending on the implementation of the service and how the service is being configured, this DNS resolution would return either a single IP, which is the cluster IP of the service, or would return the list of pod IPs. That's all great, and it's very simple. But while it is simple to use in the beginning, as Reddit scales and as we embark on a project called Worldwide Reddit, which is our project to bring Reddit physically closer to the users, we start spinning up more clusters and more regions. And we figure out that these abstractions that we had over Kubernetes basic DNS service discovery was starting to fall apart. So the service owners right now that were running in the clusters were faced with a very awkward decision. For each service they were calling, they would either need to know, is the service cluster local? In that case, kubedns works. Or is the service in a different cluster? In that case, they would need to use the address of the other cluster and use the cluster ingress. And then they need to do that as our infrastructure evolves, services move around, and this kind of like a large project. This was very complicated. Additionally, services, clients and servers, as we want to improve utilization and performance, they also need to hand manage a lot of things. We had services ranging from cluster IP, headless services, all the things that we talked before about keep alives. All these were very confusing and very hard for our users who were frankly they want to build Reddit. They didn't want to be gRPC experts or they didn't want to be experts. Also, load balancing and load balancing policies is we figure out different services have different load balancing requirements, and we didn't want them to change all the clients. So to do that, we start effectively figuring out the solution. And the first layer of the solution is, should we use a proxy or no proxy? And this is kind of the decision metrics that we use. And I think this is the decision metrics that I would use for other cases. If we went with a proxyless approach, the protocol-less approach is gRPC, which is the primary target. But proxy has a very, very big advantage that it can support Envoy, much more protocols. For proxyless, if you want to offer a very good experience, the language support cost is very high. If Reddit ever decided to use a very niche programming language, the cost of supporting gRPC would be high. We'll have to use either the C core library, whereas the proxy being out of process can support everything. In terms of isolation, which is very common, concern as we're running at scale, proxyless approach has very high isolation. You are running it is your application. You understand what's happening to it. The moment you introduce a proxy, depending on whether you introduce it as a node proxy or as a deployment proxy, you start introducing another neighborhood, another shared resource over the cluster where multiple people can start competing for the same proxy. And then the next thing is the overhead. Proxyless has very low overhead, very low overhead to medium overhead. Whereas the moment you start introducing a proxy, now you have like multiple instances of those proxies, and that consumes a lot of resources, The other thing is the operational cost. As application developers are very used to looking at their application logs, their application metrics. So a proxyless approach with code that runs within their own service is very intuitive to them and to debug with them. Whereas the moment you introduce a proxy, effectively the infrastructure team will have to build a dashboards, operations, and processes to answer the basic question: is the proxy introducing the error, or is the upstream introducing the errors? And then that's very high cost in terms of operations. So what we end up building is a proxyless approach, and here we're going to talk about the control plane. Our control plane is very simple, and it has three components. The first component, which is the core part that does the service discovery, is the component I'm going to talk the least about, because I think it's being very covered by multiple implementations. There's open source implementations for like doing similar things, and it is very standard. But I will talk about the other two components, which is the validation webhook that we run and the config map injector, which I think is more novel and more interesting. So the first thing is we have the XDS control plane. It's a simple Kubernetes controller that reconciles gRPC routes from the Gateway API project, endpoint slices and services. It creates an XDS snapshot and advertises this to the clients using the XDS clients. The second thing that we have to do is, if you used gRPC XDS implementation, you need to provide bootstrap.json, the bootstrap.json file. This poses a very interesting challenge, because now we're trying to figure out a solution that will allow us to optimize for these constraints. We want to be able to change the XDS address that the XDS server that the client is using without changing the client. And this is because we want to introduce bulkheads in case one client is becoming very, very big. We want to put them, for example, in a penalty box control plane. We also want to avoid spools and failing static. So we want something that is dynamic, but we also didn't want to introduce a spoof. And we want all this to be transparent to the service owner. So if we want to migrate how we do construct the bootstrap.json, we didn't want to tell all the service owners, hey, you need to do this upgrade. So to do that, we build another controller. We call it the config map injector, which watches for Kubernetes namespaces. And it creates a config map that contains the bootstrap file that the controller creates. Because the controller has access to the Kubernetes control plane, it can inject it and can populate the values intelligently. And the pods just have to load this config map. That gives us the operator the ability as a platform team to operate independently. And also if the config map injector is down or has any issues, the config map is always there, so we can fail statically to a value that we know that works. The second thing is the validating webhook. Most of the times in Kubernetes worlds, validating webhooks are being used by the API servers to provide a better UX. If a resource that you're about to create, the control plane would consider them as invalid, the Kubernetes control plane would just, the validating webhook would reject it. So that's a better UX for application developers. The other thing that we also try to do with the validating webhook, which is more of the implementation, is we also use it quite extensively to protect our control plane from queries of death. So imagine that a very clever user creates a gRPC route that we haven't thought about, that we can't parse it very well, and we can't create an XDS snapshot based of it, and that would cause like a segfault in our control plane. The validating webhook is running the same logic and is answering the same question. Can I use this gRPC route to build a valid XDS snapshot? And if not, and if this, let's say this crashes the server because we had a bug, fine. The validating webhook crashes. People can no longer push, but the control plane is still active. So that gives a very nice protection mechanism for our control plane. And the last part is, how do we adopt this? Okay, you build this, that's the easy part, that's easy. Now the hard part is how do we make adoption easier? A big thing for us is client-side observability, and a huge shout out to the gRPC Go community. I think generally the gRPC community are having all the metrics that we need. So we end up building and exposing the gRPC XDS client metrics. It's very useful to know what's a client's view of the control plane. The other thing is we use custom metrics plus tracing to understand the data path better. as we're making the networking more opaque to application developers, we want better observability to understand what exactly the data path we're traversing. So for example, we say that application developers might not know if the service is in the same cluster or a different cluster. They might not want to know it for configuration purposes, but for debugging or for understanding the applications, they definitely want to know it. So we want this observability to be there. And the last thing that we did is we used the CSDS endpoint, which allow us to, in the admin of the client, so we can go to any client and say, hey, what is your current XDS configuration? To see what's the configuration that it has right now. And we have the same admin endpoints in the control plane that will tell us what is the current state of the world that you have. And the other thing that we built is a sampling client. Because I think the major goal for this migration is that they should be progressive and easy to revert. So we end up building a sampling client that allows for any RPC call that you want to choose if you want to use the XDS addresses that we build or the DNS resolve, which is the default case. Sampling is, while this seems easy, we have to decide a bit of a trade-off, and this is depending on the underlying RPC implementations and the scale of the services. So you have two ways that you can sample. You can sample per RPC, or you can sample per connection. The main benefit of sampling per RPC is that each RPC call can go to either the XDS routed via the XDS dials, or via the DNS dials. So it's very easy because RPCs happen all the time. You have very, very good control over how do you roll it back. It can be instant basically. The problem that you have though is a big overhead that makes it a bit expensive, because now you have two dials that the gRPC client is going to be managing, and that means double the connections. Double the connections means double the connection overhead, which can get very expensive for large services. The alternative to that is the other mode that is offered for sampling is connection-based sampling, where in the dial establishment, you decide whether you establish an XDS dial or a DNS-based dial. So if you decide, the problem with that approach is that might require a pod restart, because most clients establish the dials once when they're beginning, and then they just keep reusing them. So if you want to roll back, now you have to change your sampling to 0 and then go that. Okay, that was a bit awkward, but it's okay. And yeah, that's it. Necessary career space. If this was interesting to you, we're hiring, and I'm open for any questions that you might have.
So you did mention about CSDS. Was it actually ever helpful in debugging a real problem? And do you remember any example of it being useful in a?
Not in not in the moment of the incident, but it has been useful for misconfigurations and understanding what the client exactly is being configured and its view of the world. And understanding any issue. So we use it as the ultimate source of truth for the client itself. So it's been more for asynchronous problems that we had there.
Do you use state of the world SOW or incremental update from XDS to the client?
Yes, let me actually go here for the architecture. We use state of the world. My understanding, and there's gRPC maintainers, so they can correct me, is that Delta is not supported by gRPC. That being said, unlike Envoy, where you have a lot of services, and it goes to an aggregate discovery service, you're gonna get batch of the request in the beginning, and then you're gonna get single responses after for the resources. So it is much more efficient compared to having a big Envoy. And the other thing that we do on the control plane side is we build a separate snapshot for endpoints and a separate snapshot for routes and clusters and all the things that change less frequently effectively. Like endpoints churn very, very quickly. So we have them in separate snapshots as the things that like remain relatively stable effectively.
And I can answer, yes, gRPC only supports the state of the world, or that can mean a little different thing, but the full, it doesn't support Delta. It's working fine. The problem is we need a good excuse to do the Delta. We would really love to do it because it's actually simpler than trying to get the other one, all the edge cases right.
And if I may, in the implementation which you have, is there a jitter between updates from XDS to the client?
Sorry, can you repeat that, the question?
Is there a jitter of the updates going from XDS to the client?
So what we do is actually we batch requests together. So our control plane has a coalescing window where we collect updates for endpoints over 5 to 6 seconds, and then we send all of them together. We update the state of the world together to avoid in very high churn periods where there's might be like very, very large churn, to spam the client with like constant amount of messages. The value is very much hand-picked right now. I think we picked 5 or 10 seconds, I don't remember. So far it's been working fine. It's kind of like in line with our previous DNS caching, DNS cache that we had before. But we might end up changing it, and if we decide that like no, there's a better value that we want to do. Yes. I'll take the silence as no more questions. I'll be around here for any questions that you might have, and thanks again for coming in.